The CPU era is ending. The real computer of the AI age is not the CPU, it's the GPU.
Wait, that sounds dramatic. CPUs run all computers today. How can the CPU era be ending?
Good question. CPUs are still essential, but the architecture of a CPU was designed for a very different world, a world of sequential computation.
Sequential, meaning step by step?
Exactly. A CPU, Central Processing Unit, is basically a sequential machine. It executes instructions in order, one instruction after another.
Like reading a book line by line?
Perfect analogy. A CPU reads instructions almost like a sentence. Step 1, Step 2, Step 3, Step 4. Each step depends on the previous one.
And that's why CPUs have only a few cores?
Correct. Modern CPUs typically have 8, 16, maybe 32 very powerful cores. Each core is optimized for complex logic, branching decisions, operating systems, databases, file systems, all those things.
So CPUs are like very intelligent workers doing complicated tasks one after another.
Precisely. But AI problems are not sequential problems.
What do you mean?
AI, especially neural networks and large language models, is basically huge amounts of linear algebra.
Linear algebra, like matrices?
Exactly. AI models are built on matrix multiplications. Imagine a matrix like this. Numbers arranged in rows and columns. For example, input data multiplied by weight matrices producing output vectors.
So the AI model is basically a giant matrix calculator?
That's a very good way to think about it. Let's say an LLM has hundreds of billions of parameters. Those parameters are stored in enormous matrices. When you type a question into a chatbot, what actually happens mathematically is something like this. Your input text, converted into vectors, multiplied with weight matrices, passed through nonlinear activation functions, repeated hundreds of times.
So the model constantly multiplies matrices.
Yes, millions and millions of matrix multiplications. And here is where the GPU becomes magical.
Why?
Because matrix multiplication is inherently parallel. Let me explain. Suppose we multiply two matrices. Each cell in the resulting matrix can be calculated independently from the others.
Meaning all those calculations can run at the same time.
Exactly. And that is exactly what a GPU architecture was designed for.
But GPUs were originally built for video games, right?
Correct. Rendering a 3D scene means calculating the color of millions of pixels simultaneously. Each pixel calculation is independent, so GPU engineers built chips with thousands of small processing cores.
Instead of a few powerful cores like a CPU?
Yes, a CPU might have 16 cores. A modern AI GPU, like the NVIDIA H100, has tens of thousands of parallel threads executing simultaneously.
So instead of reading instructions line by line, the GPU attacks the whole matrix at once.
Exactly. The GPU takes a large matrix operation and splits it into thousands of small operations. Each small core calculates one piece of the matrix.
Like thousands of students solving pieces of the same math problem.
Beautiful analogy. Now, modern AI GPUs go even further. They include special units called tensor cores.
What do those do?
Tensor cores are hardware specifically designed to accelerate matrix multiplications used in deep learning. They can compute operations like matrix times matrix far more efficiently than normal GPU cores.
So the hardware is literally built around AI math.
Yes, that's why companies like NVIDIA dominate the AI industry right now. Their GPUs were perfectly suited for the matrix-heavy workload of neural networks.
And CPUs just can't do that efficiently?
They can do it, but very slowly. Remember, CPUs think sequentially. GPUs think in parallel matrices.
So when people train huge AI models,
They run them on thousands of GPUs in parallel. Training a large language model on CPUs might take months or even years. On GPU clusters, it can be reduced to days or weeks.
And once the model is trained?
Then comes inference, running the model to generate answers. Even that still requires massive matrix multiplications, so GPUs remain critical there as well.
So, if I understand correctly, CPUs are like very smart managers working step by step. GPUs are like massive factories solving thousands of math problems at once.
Exactly.
Thank you, Mr. Professor. Now I understand why AI hardware is built around GPUs. The math of neural networks, especially matrix multiplications, fits perfectly with massive parallel processing.
Yes, exactly. And here's the deeper lesson. In computing history, the winning architectures are always the ones that match the dominant workload. In the 1980s, it was personal computing. In the 2000s, it was web servers, and now it's matrix computation. And in the age of AI, the machines that think in matrices may shape the future of computing.